great plus of experimental archaeology is that one is generally doing something worthwhile while at the same time having fun. Playing with fire particularly fascinates so many of us, and because of the many uses of fire in the past and the role of fire in our evolution, it's not surprising that there are various and numerous experiments with fire. Here, I focus on experiments with fire that have been done to provide analogues for interpretations of evidence recovered from Sibudu Cave and Borja Cave in South Africa. The sites are situated in northeastern South Africa, about 80 kilometers and 12 kilometers respectively from the Indian Ocean. Both sites have excellent preservation of archaeobotanical remains, my chief interest, and there is Middle Stone Age evidence of the presence and use of fire for a range of purposes. The experiments I describe were undertaken to understand taphonomic processes of the archaeobotanical remains and ultimately people's use of plants at the sites. While Professor Lynn Wadley, a colleague from Wits University, where I too am based, was directing the Sibudu excavations, she and I together explored the taphonomy of the charred seeds recovered from layers about 39,000 to over 70,000 years old. Specifically, we wondered about the processes whereby the seeds may have become charred. To investigate how the seeds may have been charred, we designed an experiment where we chose modern seeds and fruits of a range of size and moisture and oil content. We buried them in a sandy matrix at various depths and various distances from the center of the fire area, and we made a fire above the buried material. After temperatures had returned to the ambient temperature, we excavated and recorded the condition of the buried seeds and fruits and their location, both horizontally and vertically, relative to the center of the fire. Our results indicated that post-depositional processes were the likely reason for charring of the seeds and fruits. Applying these interpretations to Sibudu, we suggested that the archaeobotanical remains at the site had become buried, and fires that were made subsequently on the surface of the sediments that had buried the remains had provided sufficient heat to char them. In the deep past, these processes, namely burial and subsequent exposure to heat from a fire above, had facilitated the preservation of the seeds. In order to investigate further the taphonomy of archaeobotanical remains at Sibudu, I did 3 series of experiments and experimented with different matrices, different fuel moisture content, and temperature variation under an individual fire. The reason for the use of sedge culms and nutlets in the experiments will become evident later in this presentation. The results were informative, but here I reflect rather on the insights these experiments provided regarding the value of field experiments. Field experiments have often been severely criticized for the multiplicity of variables involved and the difficulty of controlling for a single variable. I have done carefully monitored, precise experiments in laboratories and recognize their importance. But the reason I continue with field experiments is that they often provide incidental observations and insights that were not part of the original objectives of the experiments. To quote Lynn Wadley, the field situation is where creative solutions are found. The focus on sedges in the experiments described was because sedge nutlets are most frequent in the Sibudu Middle Stone Age seed assemblage. After I had collected and experimentally charred the nutlets of many sedge species, Mutama Muyasia, an expert on African sedges, helped me to identify Cladium moriscus, although nutlets of other sedge species were also present, but in lower frequencies. Consideration of the various possible routes of entry of the sedge nutlets indicated that people were the most likely agents of deposition. We proposed that the nutlets were transported accidentally on sedge culms, stems, that people harvested in the river and brought to the shelter to provide bedding, defined as a surface for various activities. Further support for sedge bedding was found in the Micromorphology. Professor Christopher Miller from Tübingen University prepared micromorphology blocks of Sibudu sediments. These showed many superimposed layers of ash, phytoliths, and charred organic material. We decided to experiment and to create comparative micromorphology blocks. We collected various grasses and sedges and made repeated fires of these, one on top of the other. In each of the experiments, we burnt 5 large bundles of a particular sedge or grass, compacting the charred material after each fire. Although the result was only centimeters thick, it replicated what was present at Sibudu. Our conclusions were that sedges were brought up into the shelter from the nearby river and laid down on the shelter floor as bedding. At some stage, people burnt this bedding and laid fresh bedding above the burnt bedding. This pattern produced almost a meter of deposits around about 58,000 years ago. The behavioral implications are that people were using fire to sanitize their living areas. Apart from destroying unpleasant bedding, they might also have recognized that ash from burnt bedding would deter pests. This brings us to bedding and ash at Borja Cave. At Borja Cave, there's evidence of bedding construction and the use of ash as early as 200,000 years ago. The bedding at Borja Cave was generally placed on ash. In an experiment with ash and ticks, Lynn Wadley showed that ash limited the movement of ticks. Evidence at Borja Cave confirms that knowledge of the properties of ash, first identified at Sibudu, extends much further back. A further insight into behaviour at Borja Cave was the discovery of the processing of rich, starchy foods. After collecting and experimentally roasting numerous underground plant storage organs, Lynn and I were able to identify Hypoxis angustifolia. The rhizomes were found in hearths 170,000 years old, and what we suggested is that they were roasted in the ash. Fortunately, some were left behind. The implications of the discovery go even beyond the issues such as tool making and planning for harvesting and processing. And they suggest also social activities, such as communal interaction around a fire. In conclusion, the examples I have given provide an indication of the range of human behaviours that have been identified through experiments with fire. Behaviours such as deliberate construction of bedding, cooking, sanitizing one's living areas, and using ash to deter irritating pests. Beyond the practical implications, the fire experiments have also fueled interpretations on social aspects of behaviour of our species in the Middle Stone Age. My enthusiastic and heartfelt thanks go to everyone who helped in discussions on experiments and during the experiments themselves. Thank you to those who organised and hosted this amazing online conference. Thank you too to the directors of Sibudu and the Border Cave projects, and especially to Lynn. We collaborated on so many of these experiments, and often even before completing an experiment, we would think of another one to do. And so I say, roll on experiments, particularly experiments with fire. Thank you.